Students will be able to find the position and acceleration of a particle given an equation in parametric form. A particle moves on the curve y equals x squared so that the x component has velocity 3t minus 1 for t greater than equal to 0, and time t equals 0, the particle is at the point 2, 4. At time t equals 2, the particle is at what point? Well, there's one concept that if you wrap your head around, this is going to be a fairly straightforward process. We're going from 0 to 2. So the position at 0 plus the displacement from 0 to 2 is going to equal the position at 2. So we know the position at 0 for the x-coordinate is 2. Let's do 2 plus, and then if we integrate the velocity of 3t minus 1 from 0 to 2, that should be the displacement from 0 to 2. So dt, well, that's equal to 2 plus, and we need to integrate 3t, that's t squared times 3 halves, minus t from 0 to 2. That's 2 plus. Let's plug 2 in. That's going to be 4. 4 divided by 2 is 2, times 3 is 6, minus 2, and then minus 0, minus 0. So that's going to be 2 plus 4, and that's equal to 6. So we know the x-coordinate. We know the x-coordinate is 6, and we have this relationship right here. So y is x squared. So 636. A particle moves in the xy plane so that any time t, its coordinates are 3t minus 1 for x and t to the third minus t squared plus 5 for y. At t equals 1, what is the acceleration vector? Well, the velocity vector is 3t squared minus 2t. And then the acceleration vector is 0 and 6t minus 2. Now we're going to evaluate that when t is equal to 1. That's equal to 0, and then 6 times 1 is 6, minus 2 is 4. A particle moves along the curve 2xy equals 8. If x equals 1 and dy dt equals 2, what is the value of dx dt? So let's take the derivative. We have first times the derivative of the second, plus the second, which is y, times the derivative of the first, so 2 dx dt, and that's equal to the derivative of 8 is 0. We have 2 times, they tell us x is 1, dy dt is 2, plus we need the value for y. So if we plug 1 in for x, we get 2y is equal to 8, so y is equal to 4. So 4 times 2, and then here is what they're asking us to find, dx dt. So 4 plus 8 dx dt is equal to 0. So if we minus 4, that's negative 4 over there, and then divide by 8, dx dt is equal to negative 1/2. An object moving along a curve in the xy plane has position xt, yt. At time t equals 0 with dy dt equals 3 plus cosine of t. At t equals 5, the object is at the point 3, 7. Find the y-coordinate of the position at time t equals 1. So going from, we know they ask about 1, and we know stuff about 5. So the position at 1 plus the displacement from 1 to 5 is going to be equal to the position at 5. But they want the position at 1. Let's just leave it like that. Position at 1 plus the integral from 1 to 5 of 3 plus cosine t, that's dy dt, so 3 plus cosine of t, is equal to the position of y at 5, which is 7. So what we want is position 1, and that's equal to 7 minus the displacement from 1 to 5 of 3 plus cosine t dt. Well, we could integrate this part of this by hand, but we don't know what the cosine of 1 is. We don't know what the cosine of 5 is, so we're going to use our calculator to finish this up. So let's There we go. Turn the calculator on. 7 minus math number 9 from 1 to 5. 1 to 5 of 3 plus cosine of t, or in this case on the calculator x. And we press enter, and I did the 7 minus, so this is equal to negative 3.200.